Today's learning target. I can perform division with polynomials using both long division and synthetic division. Synthetic division is going to be a million times easier. We're just going to bear through the long division. And like I previously stated, I'm going to show you a method we do in Algebra 2 Common Core, which is reverse tabular division. I think that's easier than long division. But I'll show you every way that I know how. Yes. All right, so let's look at division in terms of simplifying. In terms of simplifying polynomials. All right, if we look at this fraction on the left, I know that if I could factor the top, I might be able to cross it out with something in the bottom. Right? So what I'm going to do here is we'll start with slip and slide. Bring the 6 out back, and now we have x squared plus 7x plus 12. Okay? So now we need two things that multiply to 12 that add to 7. Yes, x plus 4, x plus 3. Now here's a big mistake that a lot of people make. They stop there. You slip the 6 out with multiplication, you still need to slip that 6 back in with division, right? So I can't just leave it like that. I need to do divide both my back numbers by 6. Now here's another mistake you make. They know it's bottoms up. They just bring the 6s up at this point. Don't forget, we need to reduce these if we can. This is x plus 2/3, right? And this is x plus 1/2. Now we can't reduce any further. Now we're at the bottoms up stage. And if I bring my denominators up, I get 3x plus 2, and I get 2x plus 1. That is just the denominator. That is all over, don't forget, it's all over 2x plus 1, right? And the beautiful part here is what now? Yes, 2x plus 1 cancels with 2x plus 1. And my answer is 3x plus 2. That is my answer. Now we simplify, but let's not forget, isn't a fraction really division? Isn't really the numerator divided by the denominator? So I can rewrite it this way. I can rewrite it that way. I should get the same answer. I should get 3x plus 2. So let's pull away from this for a second, and let's say, what if I have the number 2, now dividing that into 394, okay? How would I do that? Yeah, like this 2, because it's one number, I look at the first number here. 2 goes into 3 one time, right? And what do? Don't I multiply my 1 times 2? And I subtract that, don't I? Yeah. 3 minus 2 is 1, and then I drop down my next number and I do the same process over and over and over again, right? So 2 goes into 19, 9 times? And I say 2 times 9 gives me 18. I subtract that, add my 1, I bring down my 4, same process. 2 goes into 14 7 times. 2 times 7 gives me 14, I subtract them, and I'm done. This is the same exact process we're going to use for this polynomial long division on the right-hand side. Okay? We are going to go in, a term at a time, multiply, subtract, bring down. Multiply, subtract, bring down. We're going to do it over and over again. And here are the keys. First, I need to make sure I'm not missing anything in either the divisor or the dividend. And what do I mean when I say I got to make sure I'm not missing anything? Well, on the inside, right here, if I would have had 6x squared plus 2, how many x's do I have here, right? There's 0, right? There's none. I have to say 6x squared plus 0x. I need to represent that with a 0 because I have none. I need a placeholder, okay? In other words, if I want to see if 2 was going into 301, I want to just divide 2 into 31, would I? I need that 0 for the tens place, don't I? Same thing. I need that 0 for the tens place. All right? So if I'm missing anything either on the inside or outside, I need to fill that in. Okay? So we happen to have everything on the inside and outside. We're not missing any terms. So we're going to start dividing. All right, let's pick this up. I have 2 terms on the outside. So I'm always going to look at two terms on the inside. I'm going to start with my first two. Okay? And the whole key here is, I want to get my first term to match. How do I get 2x to become 6x squared? What do I multiply it by?
3x squared.
3x. 3x. So here are my x's. I'm going to put 3x. And what did I do over here when I decided it was a 1? Did I multiply my 1 times 2 when I subtracted it? That's the same exact thing I'm going to do here. Then drop the next number and do it over and over and over again. All right? So, I'll take 3x times 2x plus 1. That gives me, when I distribute that, 6x squared plus 3x. This is what I'm subtracting. Now be careful, you're subtracting the whole thing. So it's a keep, change, change situation. Right? Some people can keep track of it how they do it, but I keep the first thing, I change the sign in the middle, I change all the signs on the inside. Look at that. 6x squared minus 6x squared, gone. That's why I want to make the first terms match. That's it. Alright? And what do I have if I have 7x minus 3x? 4x. And then I drop the next number and I do it all over again, just like my division problem. It's a positive 2. I've got two terms, putting them into two terms, and I want the first to match. How do I make 2x into 4x? Multiply it times 2, a positive 2, right? So let's go here. Let's put 2 and multiply it, and then that's what we subtract, right? 4x plus 2. Hey, look at that. 4x plus 2. When I have something to subtract itself, 0. And that's my answer. Should be. It's the same thing out here. It's the same problem. I should get the same answer. It's not too bad, but I'm going to show you even an easier way. Now I'm going to show you the way they kind of have us do it in Algebra 2 Common Core, and I've never shown it this way in PreCalculus, but I think it's worth showing you guys, and you guys can see which way you prefer better. I actually like doing this reverse tabular method myself. So, if I were to multiply, some people can FOIL, and some people use that box method, right, where they make a box and multiply things together. For example, if I were to multiply 2x plus 1 and 3x plus 2, I would multiply it, it should equal this, okay? So some people say 2x plus 1 times 3x plus 2, and some people can FOIL it, which is fine. Some people do this, 3x2 times 2x and 1, and they do the box method, right? See what I'm saying? And if I multiply this out, 3x times 2x gives me 6x squared, and then 3x times 1 is 3x, this gives me 4x, and this gives me 2. And how I work this out is, I diagonally add these. I add 6x squared to nothing. There's no other box diagonal with it, so that stays 6x squared. These two combine, 4x and 3x, 7x. There's no other box to combine this with, 2. Look at that. That's the answer here, isn't it? Well, it's easy to multiply, but now, for our sake, we know 2x1, we don't know what the answer is. We're working this way now. Okay? We're going to work this way. We have what the answer should be when we multiply. That's either this, or it's this. Okay? Think of it this way. If I have 10 divided by 5, what's the answer? 2. You want to know why? Because 5 times 2 gives me 10. So this times this is going to give me this. This times whatever the division answer is, 3x plus 2. When I multiply, it's this. It's working backward. I'm just going to work backward with the box method. They call it reverse tabular. The only thing you got to be careful of is when I set this box up, I know it is too tall. Here, there's one term and two terms. I know it's too tall, but how wide do I know? How far this way is this going to go? It's actually a little cheat. It's a little cheat. What is the biggest exponent on top of the fraction right here? The biggest exponent. Squared is 2. What's the biggest exponent here? It's a 1, right? You always subtract them and then just add 1. That'll always tell you the width. So I can take 2 minus 1, which is 1, and I always add 1. Doesn't matter what this is, I always add 1. And I know it's going to be 2y. 1, 2y. Okay? Montrell actually came up with that. It was pretty good. So, all right. I need to divide these. So I'm going to reverse multiply. I know what my answer should be. That's this right here, the answer. So, if I have a 6x squared here, there's only one box that should be outputted from. This has to be 6x squared here. See what I'm saying? So now I can reverse. What do I multiply 2x by to get 6x squared? 3x. Now look how easy this is. I can fill in this box right here. What's 3x times 1? 3x, isn't it? Now, wow, I can fill this box out through adding. What do I add to 3x? You need 7x? 4x. Oh, now I can do this. 2x times what is 4x? Positive 2, right? Hey, now I can do this box here. What's 2 times 1? And that's right. Look at that. It's a lot easier for people to multiply and add than it is for people to divide and subtract. So a lot of people prefer that way much better. There's one issue. When this number here, you always start top left, but when that number here does not match the number that should be outputted, that means you're going to have a remainder. And I'll show that to you in a second. We can do this either with long division or with reverse tabular. Okay, if you want to do long division in paper, that's fine. I'll do reverse tabular up here on the board, whatever's easier for you. So I know x plus 5 is going into here. So I know if I multiply x plus 5 by whatever my answer is, this is what it'll become, right? Like if I had, again, if I had 5 going into 10, it goes in there twice, because 5 times 2 gives me 10. Okay? So I know I've got an x and a 5 here, so I know it's too tall. How wide is this? 2 boxes wide. I don't know. I take the biggest exponent here, which is 2. Subtract the biggest exponent here, which is 1. And I always just add 1 onto the end. 2. So I know it's 2y. Bang, bang. My answer. Is there anything missing here, by the way? Is there any terms missing? No, I have an x squared, I have an x to the 1, and technically this is 0 x's. I have them all. So there's nothing missing. So this corner gives me the first one, 4x squared. When I combine these two, that should give me my next one, 23x. And this last one, there's only one box. It should give me negative 16. We will start top left and work our way back. If you want to do long division, again, go ahead. That's fine. You can go ahead and do that. But I want to show you an example where we might get a remainder. Okay? This has to be 4x squared. It's the only box that gives me this. So what do I multiply by x? 4x. Times x gives me 4x squared. Oh, sweet. Now I can do this box. What is 4x times 5? 20x. Sweet. Now I can do this box. What do I combine with 20x? Give me 23x. 3x. Oh, sweet. Now I can do this. What times x is 3x? 3, right? A positive 3, right? Sweet. Now I can do this box down here. What is 3 times 5? Here's where you know you have a remainder. Does that match what it's supposed to be, negative 16? You want to know how you get your remainder? Here, this number right here doesn't match. Bang. Something's wrong. How do I get from here to here? What do I add or subtract, whatever, to 15 to make it negative 16? I need to take 15. Well, think of it this way. If I have 15, I add what to get to negative 16? Don't I just subtract 15 from both sides? So this is my remainder. That's a remainder. That's it. That's a remainder. So what's my answer? It's 4x plus 3, the remainder of 31. And if you were to do this long division, after you break down your 16 and you find your last number and subtract, you would have negative 31. I gotta put you on a cane. Negative 31. Good call. Okay, take a look at this. We no longer have two terms on the outside of the divisor. We have three terms. 2x squared plus x plus 1. Our dividend, the biggest term is 2x to the fourth. Is there anything that you notice that maybe we need to make any alterations with? Okay. I mentioned this earlier, but now we're going to put it in your notes, officially. You need to fill in your missing terms. In either one, on the outside or inside. If there's something missing, you need to put 0 there. If I want you to write me a check for $1 million, and on your check you have this number right here, it isn't $1 million, it's $1. You're missing the zeros for the 100,000, 10,000, thousands, the hundreds, the tens, and the ones. You'll have the ones. That is very different. If you write me a check with that number on it versus this number, you need to write the zeros to represent the places that are empty. And right now, in the dividend, which is on the inside here, what terms are missing? If I have an x to the fourth, I gotta have an x to the third, right? Which means I should have an x squared that's not there, which means I should have an x that's not there. I have a number without an x or 2. So technically, I'm missing my x squared and my x's. Yeah, you just put 0. You put 0x squared and 0 x's. You would rewrite it like 2x squared plus x plus 1, dividing into 2x to the fourth minus x cubed plus 0x squared plus 0 x's minus 2. You need to have them there. You need to. Now, if I was going to do long division, I have 3 terms on the outside, right? I would have to start looking at 3 terms on the inside. I'm going to do tabular because to me, otherwise it'll go down. And it's a lot to keep track of. You got to distribute into the 3 into the divisor. You got to list them down here. You got to subtract. You take it from the 3, drop down 1. It just seems a little bit heavy. You can do it. It's fine. Some people like it better depending on their organization. I will show you the box method. Okay? The reverse tabular. So, question. I know how tall is my tabular, is my tag, I guess, are my tags. How tall are the tags going to be? 3, right? I'm going to have a 2x squared, a positive x, and a 1. So this is 3 tall. How wide are they going to be? What do I do? I take the biggest exponent on the inside. I subtract the biggest exponent on the outside. And I add 1, right? That's the width, 3 right there. So this is going to be a 3 by 3 cube, which is nice. Okay. And we know wrapped around the outside is going to be our answer we multiply right here. So this should give me my 2x to the fourth. When I combine these 2, I get negative 1x cubed. When I combine these 3, it should be 0x squared. What should be next? Yeah, 0x's, right? And this should give me what? A minus 2. Let's do this. Okay. Start in the top left and work our way back. So this has to be 2x to the fourth, doesn't it? Which means, what do I multiply 2x squared by to make it 2x to the fourth? X squared. Now, the beautiful part here is I can fill in this whole left column now. X squared times x, that's x cubed. X squared times 1, that's x squared, yeah. Now, look at this. I'm going to get this. X cubed, if I got to combine it with what to give me a negative 1x cubed. Don't forget, it's the 1, isn't it? And it's a negative 1, right? So how do I go from 1 to negative 1? Remember, we're adding when we go or subtracting, whatever. Adding to when we go diagonal. We're combining. This isn't multiplication. This is just adding and subtracting. Yeah, a minus 2. Subtract 2, right? So this will be a minus 2x cubed here. That's what will make that work. If I have a minus 2x cubed plus 1x cubed, I have a minus 1x cubed. Which means now I can do this. What do I multiply by 2x squared to get negative 2x cubed? Negative x. because a negative times 2 is negative 2. And x times x squared is xt. Now I can fill that middle column. Let's fill this one. What's negative x times x? Negative x squared. What's negative x times 1? Negative x. All right, top right. Now I need to combine this with the other two here and here, and it should be 0. Well, right, what do I have here? What is that? It'll be 0, right? Don't these already cancel out? Negative x squared and x squared already give me 0, so this has to be 0 x's. X squared. Which means what? How do we get 0 x squared? So you're going to multiply this times 0. Interesting. Which means, wouldn't all these be zeros? Yeah. Okay, well, let's combine these two right here. Yes, there is a remainder, and it's not just one digit. It's 2, because if I combine 0 and negative x, that doesn't give me 0 x's. So what is 0 minus x? It's negative x, right? Well, how do I get from negative x to 0 again? Don't I just add an x? And how do I get from 0 to negative 2? How do I get from 0 to negative 2? I subtract 2. So that's what my remainder is. Negative 2. X minus 2. My remainder is x minus 2. Where they stop matching, that's where you figure out your remainder. Well, okay, when I combine 0 negative x, that gives me negative x, but I need 0 x. So what do I do to negative x make 0? I just add an x to it. Okay, well I have 0. How do I get the negative 2? Well, or excuse me, yeah, how do I get the negative 2? Well, I subtract 2. So my remainder is x minus 2. So if I were to answer this, it's x squared minus x with the remainder of x minus 2. That's a lot. Synthetic division, my God. All right, so here we go. We take the variables out, which is beautiful. We just deal with numbers. So, first of all, my divisor must be 1x plus or minus a number. It has to be 1x plus or minus a number. See right here? There's 1x plus or minus a number. That's good. It works. Check. So, when I set up my synthetic division, I'm just going to keep that number. I called it k here. So I'm just going to keep my 5. Forget about the x. Boom, done. Screw it. Gone. I just keep my 5. And I keep the coefficients in the dividend. Okay? I keep my 4, my 23, and my minus 16. Forget about the variables. All right? And what it looks like is this. And what it looks like is that right there. So that just separates it. This just means this is the number going in. Okay? This is what you're dividing into right there. Okay? It's still a type of division. So we've got to separate what's going in and what's it going into. Okay. Where? 23? Don't worry about it. It's positive. There's no sign in front of it. It's positive, right? So we're going to bring down the first term in the dividend. So what I'm going to do is just draw a line like this underneath it. Bring down my first number. That's a 4. Ready? I multiply the first term. So multiply first term by divisor. So I multiply this first term, which is a 4, by my 5. What's 4 times 5? 20. Guess what? I put that up here. I subtract that from my next one, so I subtract it. What's 23 minus 20? That's what I do it again. It's 5 times 3. I subtract them. What's 16 minus 15? No, 16 minus 15, excuse me. 16 minus a negative 15 would be a positive, or negative 1. Negative 31. Guess what? This last term? Yep. You repeat until you're done. This last term is always the remainder. This is your number without an x. This is your number with an x to the first. If you had another, you keep on going. It'd be x squared and so forth. So what's my answer here? It's 4x plus 3 with the remainder of negative 31. Does that look familiar? Wasn't it the second problem we did? The second problem we did. Look how much easier that was when we took out the x's. Isn't that crazy, synthetic? It doesn't always work, so you need a 1x plus or minus something. This needs to be linear. When they say linear, you know that equation y equals mx plus b? That's how it has to be. And the axis have a 1. Okay. Once you do that, just bring down your numbers. I brought down the 5, the 4, the 23, the negative 16. Bring it down, multiply, subtract. Multiply, subtract. And there you go. The last number is always the remainder. If that last number is 0, there is no remainder. Alright? Okay. Alright. So, what we do is we keep this number. And what else do I keep? The 2, the negative 3, the negative 5, and the negative 12. Thank you. And what's the first step? I do what? Yeah. And I multiply this. So 2 times negative 3 gives me negative 6. And don't forget, subtract. I get 3. So when I subtract a negative, it's like making it positive, right? Then what do? Negative 3 times 3 gives me negative 9. Don't forget I subtract it. That gives me 4. Perfect. What's next? Negative 12. Good. That's negative 3 times 4. And I subtract it, which means 0. I always box it off and say this is my remainder. 0. My 4 is my number without an x. My 3 would give me x. My 2 would be x squared and so forth. So my answer, 2x squared plus 3x plus 4. Got a remainder. And that is nice and clean. Love it. Unfortunately, the first problem isn't nice and clean. Alright? What term am I missing here? The x. So this is going to be 3x cubed plus 5x squared plus 0 x's plus 7 because I don't have my x's here. And I'm still going to have 3x plus 2 go into it. Let's reverse tabular. If I have 3x and 2, how wide is this? 3. It is 3y. Which means bang, bang, bam. And wrapped around the outside is which term? What do I put on the outside? 3x cubed, 5x squared, 0x, and 7. Good. This has to be 3x squared. Which means what goes here? Cubed. Oh, dang, it's cubed. Squared goes here. It's x squared. Man, 2 can't. I gotta write you guys' names down. Which means I can now fill in this bottom left box. What goes in here? 2x squared. Don't forget, it's x squared times 2. So now I can fill in this box. What do I add to 2x squared to get 5x squared? 3x squared, which means I can do this. What times 3x is 3x squared? 1x. Which means now I can fill in this box. What goes there? Yes, 2 times x, right? 2x, which means I can fill in this box. What do I add to 2x to give me 0 x's? Negative 2x. Holy cow, here's what the problem is. Here's what the problem is. Is this what you guys ran into and did it this way? Lord. How do I make, and this is terrible, how do I make 3x? First of all, let's go back and make sure we did it right. Well, we have 3x cubed, that's x squared times 3x, is 3x cubed, which means 2x, okay, those are all positives, times x squared is 2x squared, it's 3x squared, it's 2x squared, okay, it's x, this is 2x, for 1, 0, it's negative 2x, How can I get, what do I multiply? 3 times what? We'll call this f. Gives me a negative 2. How do I solve for f there? If I have 3 times f to give me negative 2, how do I get f alone? divide by 3, right? Wow, that's tough. Minus 2/3? Wow, yeah. If you take 3x and multiply it by minus 2/3, you get a negative 2x. That's a tough one. That's not easy. So now, what goes here? I got to multiply 2 times negative 2/3. Holy cow, what is that? Negative 4/3. This is negative 4/3. What's my remainder? I'm going to set that up. That's a tough one. Negative 4/3 plus what? I'll call that f equals 7. I got to add 4/3 to both sides, don't I?
Yeah.
F equals 7 plus 4/3. I'll change this to a fraction with a 3 in the bottom. That's 21 over 3 plus 4 over 3. What is that? 25 over 3. That was challenging. So I need to add 25/3, and that's my remainder. That's tough. Here's the answer with the remainder. That was really tough. Good job, people. It was a lot of lessons today, a lot of lecturing.